No gas, the appliance won't fire. Episode 48 of the Gas Service Animated Series. This is the other half of no gas, where there's gas at the appliance, but it won't light or won't stay running. And the way through it is not to poke at parts, but to follow the sequence of operation. Does it call? Does it try to ignite? Does it prove a flame? Find where the sequence stops. Start at the manual valve because it's embarrassing to miss. Handle in line with the pipe is open, crossways is off, and watch for the deceiver. A valve with a broken stem or sheared drive turns freely to the open position, while the ball inside never moves. The handle says open, but there's no gas. If the handle spins with no stop, suspect it. On a standing pilot appliance, the pilot is the gatekeeper. A thermocouple sits in that little flame and makes a tiny millivolt signal, and that signal is the only thing holding the main gas valve open. If the pilot's out, from a draft, a dirty pilot orifice, or if the thermocouple is dirty, misaligned, or worn out and can't prove the flame, the valve closes for safety and stays closed. So a dead standing pilot appliance is very often a pilot or a thermocouple, not a gas supply problem at all. On electronic and modern appliances, the gas valve is a solenoid that opens when it gets its call, commonly 24 volts. There's a test that ends the argument. Put a meter on the valve. If it's getting its voltage and you hear that click and it opens, the valve's good. Voltage present, but no click and no open, the valve's bad. No voltage means the problem is upstream of the valve, a control or a safety that hasn't let it fire. And upstream of that valve sits a chain of safeties whose whole job is to cut the gas, and any one of them open stops the show. A high limit trips on overheat, most often a plugged filter choking the airflow. A flame rollout switch trips when flames roll out of the box. A blocked vent or spill switch, and the pressure or vacuum switch keep the burner off if the exhaust can't get out. A water heater has its energy cut off. These aren't failures to bypass. They're doing their job. Find which one's open and fix why. If it calls and tries but won't stay lit, look at the ignition and the proving. A hot surface igniter or a spark control runs a set number of trials, and after failed tries, it drops into a soft lockout and quits. Sometimes reset by cycling the power, but only after you know why it failed. A flame sensor that can't prove the flame will cut the gas within seconds. And don't forget the plain ones. Low manifold pressure, a plugged pilot or burner orifice, the thermostat, the power. So the method never changes. Is there a call for heat? Does the appliance attempt to ignite? Does it prove a flame and stay lit? Each answer sends you to a different place. No call is a thermostat or a safety open. Tries but won't stay is ignition or flame proving or gas. Nothing at all is power or the valve. You're not guessing parts. You're reading where the sequence dies. And you finish it like the startup episode taught. Once it's firing, you place it back in operation properly. Check the manifold pressure to the nameplate, watch the flame, and on a draft hood appliance, prove no spillage after 5 minutes with the house at worst case. A relit appliance isn't done until it's proven safe. The appliance in one breath. Follow the sequence: call, ignite, prove flame, and find where it stops. Check the valve, including the broken stem deceiver. A standing pilot is a thermocouple story. An electronic valve is a voltage test. A whole chain of safeties will cut the gas by design. Find the open one, fix the cause, never jumper it, and prove it's safe before you leave. That's the no gas season, from the street to the burner.